0, 1 matrix. 0, 1 matrix. Given an m into n binary matrix is called mat. Return the distance of the nearest zero for each cell. The distance between two adjacent cells is 1. Okay, when we look at this example, if it is 0, we don't have to go anywhere. So the distance is gonna be just 0, 0, 0, 0, 0, right? Only if it is not 0. That means if it is 1, because it is binary, so it can be just 0 or 1. Only one of 0 or 1, right? Okay, so only when it is 1, we need to calculate the nearest 0 distance, right? The distance of the nearest 0. Okay, in this case, the nearest case is just every neighbors are 0, right? Wherever she go, wherever this one is go, just one cell, right? So the distance of the nearest 0 is just 1. So the result is just the same with this diagram, okay, with this array. And then this case 0, 0, 0, we don't care. And then only if it is 1, we need to check every neighbors. If they are 0, we don't have to care about the other cells, which is 1, because if it is, we can reach with one cell, we can just say, yeah, this is just a distance, right? So in this case, this 1 can go to 0 cell only one step. So just 1, this one is close to the 0, just 1, this one just 0, close to the 0, so just 1. For this 1, I1, I2, comma, J1 at the time, there is no 0 in its neighbors. So how we are gonna do this? So in this case, we will just check. We need to check every neighbors. If it is not, we need to check another's neighbor, right? This neighbors, this neighbor, this neighbors, and then we need to look for the 0 areas, yeah, 0 array, I mean 0 place, until we got the 0 we have to look for, right? So if in this case, we will just depends on the numbers of 1. If the numbers are, most of them are 1, we need to look for many places to get 0, to reach to the 0, right? For example, I have an example. For example, in this case, if we are here, we need to look for its neighbor 1, 1. No, they are not 0, so we cannot reach with one step, right? The distance is 1, so okay, we cannot go there. So we will just look for this neighbor, right? This one and this one, because okay, they are not 0. Okay, we will just keep looking for, right? So now we just 0. So okay, to reach this one have to go one step, and then this one has to go one step. So this is just the same with 1. This one can go to 0 with the distance 2, right? 2, and then 3, and then we got 4. So the time complexity is gonna be order of m into n, because we need to do every elements, right, in this array. So okay, this case every time when we see this 1, we need to look for the 0, right? If it is not 0, we will keep looking for its neighbor, right? So for me, I don't want to look for every nodes. So the way I'm gonna do is, every times when I reach to a node, I will just check the above, the elements on its above and the elements in front of that node. And then, for example, in this case, I will check if it is I 0, 1, 2, 0, 1, 2, right? If it is I 1, comma 1, I will just check I minus 1, comma j, and I, comma j minus 1. I will just check these both of them first, and then I will look again. If it is 1, I will just put the other large integer values, and then because I will compare with the minimum values, right? And then for the first time, I will just check the elements in front of that, and the upper elements on its index, and then in another loop I will just check its, for example, if it is I 1 comma 1, right? So 1 comma 2, and then 2 comma 1, and then for the in the first loops I check those two, right? And in the second loop I check those two, and then I can get the distance of the nearest 0 for each cell. Yeah, I think you can see the logic I'm talking when you see the code, and then you can trace this one, how we got this one. Okay, to know the length, rows numbers and column numbers, I will just do like that. This one is the row numbers, and then so your column number is math 0 dot length. Okay, so for the first time I will loop. In this case we will just save 2 order of n plus m into n, so we reduce the numbers of 1, right? So we only have to do order of m into n. There is no multiplication now. Okay, so 1i less than row, and then I plus plus, and then for integer j equal 0, and then j less than row and column, and then j plus plus. Okay, so if math I comma j equal 0, if it is 0 we don't do anything, right? And then we will just keep it, right? Only if it is not 0. And then we will change that value with the random ledger integer. Like for example, now I'm gonna plus okay, and then if, because we have to check above values and the last value, right? So in this case, if we want to check in these elements, there is no small I, there is no small j, right? So we need to check I is greater than 0 or not. If I is greater than 0, we need to compare, and then we will take the minimum value. In its value, and then I told you like I minus 1 and j, right? And then with plus that one, because here 0, here 0, right? If it is 0, we will just take plus 1, because we can reach there, because the distance between those are 1, right? So we have to plus 1. The same way, if j is greater than 0, I j minus 1. Okay, so this one is our first loop, and then in our second loop we will go from the latest elements to the first element, right? Because we need to check the elements behind the behind the elements, behind that area, and then the area below them, below it, right? Okay, row minus 1, because we will start from the last elements, and then greater than equal 0, I minus minus, and that the same way j equal minus minus, and then greater than equal 0, and then column minus 1. If it is if I equals 0 0, we don't need to do anything. If it is not, we don't need to do anything this time. And then if I is less than column minus 1. Oh no, I is root, right? And then j less than column minus 1, we will compare these elements with if it is I comma j at the time I comma j plus I comma j plus 1, right? Okay, I comma j plus 1. If it is I, this one, okay, this one is I comma j at the time, we will need j plus 1 comma I, and then I plus 1 comma j, right? I plus 1 comma j. Okay, so by doing this way, we change the original maps two-dimensional array, right? We don't need any extra memory. We just create the two variable. It's called rows and column, right? Okay, and then we only need to return the two-dimensional array back. Okay, here column and column. Okay, so let's see what's gonna happen when we submit. Okay, so we save a lot of memories, right? Okay, so that's it. Thank you.